Hello, everyone. Welcome to Swayam's online lecture series on the topic Data Management System. Myself, Muhammad Abdullah Bukhari, working as a professor in the Department of Computer Science at Aligarh Muslim University, Aligarh. I am pleased to have you join me today as we explore the fascinating realms of databases, database management system. In the few minutes, we will discuss data modeling using UML, relational model, and language and systems. This lecture will enhance the conceptual clarity on few very important topics of database management system, including UML and relational models. In the previous session, we have discussed enhanced entity relationship, object modeling. Before proceeding with today's agenda, I would like to discuss some questions that I had given you in the last class. The first question: what do you understand by enhanced entity relationship and explain in detail? The answer is enhanced entity relationship modeling extends traditional entity relationship diagrams with additional features to better represent complex data relationships. EER introduced concepts such as inheritance, specialization, and generalization, allowing entities to inherit attributes and relationships from parent entities. It also supports the modeling of various types of relationships, including one-to-one, one-to-many, and many-to-many. Aggregations and compositions relationships can be depicted, enabling the representation of complex data structures. Enhanced entity relationship modeling offers increased flexibility and expansiveness in database design, providing a more accurate and comprehensive representation of real-world scenarios compared to traditional ER diagram. The next question was, describe the advantages and disadvantages of object-oriented data model. The answer is, it is used to add semantic content that can be well understood by the user. It is used to make the code resemble real-world objects. Database integrity can be achieved. A structural and database independence is created. We can store pictures, audio, video, and other types of data which has previously impossible to store earlier. The third question was, what is object modeling and how does it improve the representation of entity in ER diagrams? The answer is, object modeling is a technique used in database design to represent real-world entities and their relationships using object-oriented principles. It enhances the representation of entities in ER diagrams by introducing concepts like inheritance, encapsulation, and polymorphism. Object modeling allows entities to inherit attributes and behaviors from parent entities, promoting code reuse and simplified database design. Encapsulation ensures that data security and abstraction. Encapsulation ensures data security and abstraction, while polymorphism enables versatile modeling of entity attributes and relationships. Overall, object modeling enriches ER diagrams with a more intuitive and expressive framework, enabling clear representation of complex data structures and relationship in database system. The fourth question was, what are the constraints ER diagram? Constraints plays a crucial role in defining rules and conditions that the data in a database must adhere to. These constraints ensure the integrity, accuracy, and reliability of the information stored in the database. There are various types of constraints commonly used in a diagram. Primary key constraints, foreign key constraints, unique constraints, check constraints, default constraints, and the last is not null constraints. The not null constraints ensure that a specific attributes cannot be contained in null values, requiring that all records must have a value for that attributes. So the agenda of the today lecture is to discuss unified modeling language, relational model, relational languages, and relational systems. So very first, we will discuss unified modeling language. Unified modeling language is a standardized modeling language used in the field of software engineering and by extension in a database management system. UML provides a set of visual notations for representing the design and structure of systems, allowing developers, analysts, and stakeholders to communicate and understand complex systems more effectively. In the context of DBMS, Unified Modeling Language can be applied to model various aspects of database design, including conceptual, logical, and physical models. In the conceptual modeling phase, Unified Modeling Language class diagram can be utilized to represent entities and their relationships. Classes and UML correspond to entities in the database, and association capture relationships between these entities. Attributes of entities can be illustrated within the classes, offering a clear depiction of the data model. Attributes of entities can be illustrated within the classes, offering a clear depiction of the data model. Next is for logical data modeling. Unified modeling language activity diagram or sequence diagram can be employed to illustrate the flow of data and operations within the system. This can be particularly useful when designing the interaction between the different components of database or when modeling complex queries or transactions. And the third, in the physical modeling phase, UML deployment diagram or component diagrams can be applied to represent the physical architecture of the database system, including servers, databases, and their integrations. This helps in visualizing the distribution of components and ensuring that the physical design aligns with the system requirements. Unified modeling language also support the modeling of state transitions using a state diagram, which can be valuable in representing the life cycle of entities within the database. A state transition can depict changes in the status of entity, providing insight into the temporal aspect of data. Additionally, if we talk about UML, then we could say that UML collaboration diagram or communication diagrams can be employed to showcase the interaction between the different components or systems in the distributed database environment. These diagrams can be illustrated. These diagrams can be illustrate the flow of data and control between various entities and systems, aiding in the design of distributed and interconnected databases. The unified modeling language serves as a versatile and standardized tool for modeling and visualizing different aspects of database management systems. Whether applied in conceptual, logical, or physical modeling phase, UML provides a common language for communication among stakeholders involved in the database design and development process, contributing to a more effective and collaborative design approach. Let us discuss different types of UML diagram. There are different types of diagram. The first is class diagram. Class diagram is a static diagram. It represents class diagram is a static diagram. It represents a static view of an application. Class diagram is not only used for visualizing, describing, or documenting different aspects of a system, but also for constructing a suitable code of the software application. Class diagram describes the attributes and operations of a class and also the constraint imposed on the system. The class diagrams are widely used in modeling of object-oriented systems because they are the only UML diagrams which can be mapped directly with the object-oriented language. Class diagram shows a collection of classes, interfaces, associations, collaborations, and constraints. It is also known as a structure diagram. The main purpose of class diagram, it analyzes and designs a static view of an application. It describes the major responsibilities of a system. It is the base for component and deployment diagrams. It incorporates forward and reverse engineering. Benefits of the class diagram. It can represent the object model for complex system. It reduces the maintenance time and providing an overview of how an application is structured before coding. It provides a general systematic of an application for better understanding. It represents a detailed chart. It represents a detailed chart by highlighting the desired code which is to be programmed. It is helpful for stakeholder and the developers. Next component of UML is a class diagram. The class diagram is made of three sections. Upper sections. The upper section encompasses the name of the class. A class is representation of similar objects that share the same relationships, attributes, and operations and semantic. Some of the following rules that should be taken into account while representing a class are given below. Capitalize the initial letter of the class name. Place the class name in the center of the upper section. A class name must be written in the bold format. The name of the abstract class should be written in italic format, which is given in the slide. Middle section. The middle section constitutes attributes which describe the quality of the class. The attributes have the following characteristics. The attributes are written along with the visibility factors, which are public, private, protected, and package. The accessibility of an attributes class is illustrated by visibility factors. A meaningful name should be assigned to the attributes, which will explain the uses inside the class. Lower section. The lower section contains method or operations. The methods are represented in the form of list, where each method is written in a single line. It demonstrates how a class interacts with data. How to make a class diagram. These are the steps we have to follow to make a class diagram. Open a blank document or start with a template. Enable the UML shape library. One on the left side of the Lucid chart editor, click Shapes. Once you are in the Shape Library Manager, click UML and click Save. From the libraries you just add, select the shape you want and drag it from the toolbox to the canvas. Model the process flow by drawing lines between shapes while adding text. Next is object diagram. Object diagrams are derived from the class diagrams. So object diagrams are dependent upon the class diagrams. Object diagrams represent in an instance of a class diagram. The basic concepts are similar for class diagram and object diagram. Object diagrams are represent the static flow of a system, but this static flow is a snapshot of a system at a particular moment. Object diagrams are used to render set of objects and their relationship as instance. Main purpose of object diagram: forward and reverse engineering. Next is object relationship of a system. Third is aesthetic view of an interaction. And the last is understand object behavior and their relationship from the particle perspectives. Benefits of object diagram: detailed insight into relationships. They offer a detailed overview of relationships and collaborations between instances and of a class. They offer a detailed overview of relationships and collaborations between instances of a classes. This helps in understanding the specific interactions and dependencies among objects. Implementation guidance. During the system implementation phase, object diagrams assist developers in building and testing the actual existence of class. Implementation guidance. During the system implementation phase, object diagrams assist developer in building and testing the actual instances of classes. They provide guidance on how to represent object in codes. Integration testing assistance. They are available for integration testing, allowing tester to evaluate how different objects collaborates and exchange information. This ensures that integrated components of a system work seamlessly. Validation of code implementation. Developers can use object diagrams to validate that the actual code aligns with the intended relationships and interactions specified in the design. This helps maintain consistency between the design and the implementation. How to draw an object diagram. Identify classes. Determine the classes relevant to the scenarios you want to depict. Classes are the blueprint that defines the attributes and behaviors shared by their instances. Identity object. Identify specify instances or object of each class that you want to include in the diagram. Identify specific instances or objects of each class that you want to include in the diagram. Create object boxes. Draw a rectangle to represent the specific instances or objects of each class. Write the name of each object inside the box. Add attributes and values. Inside each object box, list the attributes of the objects along with their specific values. Draw relationships. Connect the object boxes with lines to represent relationship or association with instances. Use arrow to indicate the direction of association if necessary. Label the relationships with multiplicity and role names if needed. Label the association lines with a verb or phrase to describe the nature of the relationship. Review and refine. Review your object diagram to ensure it accuracy. Review your object diagram to ensure it accurately represents the system's structure and relationships. Refine the diagram as needed based on feedback and requirements. Use tools for digital drawing. While you can draw a class diagram on paper, using digital tools can provide more flexibility and ease for modification. Unified modeling language, modeling tools, drawing software, or even specialized diagramming tools can be helpful.